Hey there, this is Kung Fu Physics. We're working our way through the practice physics GRE problems. I got a pretty easy, okay, maybe like the easiest physics practice GRE problem ever. I think I've said that before, but honestly this one is really an easy point, so I want to kind of hurry through it. It's a mechanics problem. We're looking at one on the 1986 exam and number 7. Number 7, 1986 practice physics GRE. It looks something like that. It's got a diagram and everything. So why don't you flip to this one, and I'm actually just going to hold it up there because, like I said, this is an easy one. I'd like to rather hurry through it. So as usual, I tend to glance at the answers. Commentary on the answers is pretty short. It's some type of angle we're looking for. The only interesting part that I see is answer E, that is substantially, a little different, 45-degree angles. Maybe conceptually I can either pick or eliminate that answer. But let's move right into the problem. I know my print off of 86 is a little fuzzy, sorry. Hopefully that's okay. Number 7, a 2-kilogram box hangs by a massless rope from a ceiling. A force slowly pulls the box horizontally to the side until the horizontal force is 10 newtons. The box is then in equilibrium as shown above. The angle that the rope makes with the vertical is closest to. And so, as a physics undergraduate student, you probably did 1,000 of these types of problems in freshman physics. And when I solved this problem, blazed right through it, and I took some shortcuts just because it is so simple. Once you recognize something as truly being simple, you should run with it. And so I just, for me, the easiest thing to do is to look at this triangle. I mean, this is what popped into my head immediately. I know the box is here. I know there's a force of 10 newtons going that way on the box. Force of 10 newtons going that way. It's at equilibrium. The forces have to be equal and opposite to have zero acceleration. So I know that this force, this is the tension. The hypotenuse is the tension in the string or whatever. I'm drawing my vectors there just to be a little more pedantic, but of course on the physics GRE you just be blazing through this problem. So really quickly, I just set up some relations here. I just said t sine theta is equal to 10, gotta be, right? And t cosine theta, this side, has got to be equal to mg. And I didn't even write mg because in the physics GRE we're always assuming g as 10 meters per second per second. So it's just the mass 2 times 10. So I just wrote 20 right off the bat. And so to solve this problem, I was just blazing through this. I was even doing this in my head. I was manipulating t equals 10 over sine theta, t equals 20 over cosine theta, and putting t equal to t. So I said it. Hopefully I don't want to write it. So I just say 10 over sine theta equals 20 over cosine theta, because I don't need t or want anything to do with t. I want theta. And so there we go. And then I get into this manipulation. Since I already looked at the answers, I know that one of the answers is arctan. Sine is one answer, or two answers, but arctan is one of the answers. And so I have cosine and sine there. So immediately when I saw that, I knew it had to be the arctan answer I was going for. So I just, cross multiply. I get sine theta over cos theta equals 10 over 20, or tan theta equals 1/2. And so theta equals inverse tangent, or arctan. I guess if somebody had never seen that notation before, arctan, what is that? They could get confused, but what are the odds of somebody going through 4 years of physics classes and not seeing that before? Not very good. So theta equals arctan of 1/2. Arctan of 1/2 again, sorry it is fuzzy. That is answer A, arctan of 0.5. So we pick answer A and move on, and hopefully score a very easy point off of that. So yes, the physics GRE is a beast of a test. It's got a lot of very difficult material for various reasons. It's also very, very tricky, but in this case, easy problem, easy point. You really want to zero in on those and recognize them as soon as you can, and make sure you get those types of problems right, done quickly. So I think that's all for today. It's going to be a short video. As always, Kung Fu physics means, if you look up the literal translation of Kung Fu in Cantonese, I think, Chinese, it means hard work. So as always, study hard for the physics GRE and anything else you're doing. I'll see you next time.